Hi everyone, my name is Migara Liyanage. I would like to present a summary of research activities that were carried out in 2022. My research is mainly on energy conservation and climate change mitigation. My research is carried out under two main themes. The first one is real-time domestic energy optimization for energy conservation using artificial intelligence techniques. The second theme is energy economic environmental modeling for climate change mitigation. So the first topic, real-time domestic energy optimization for energy conservation using artificial intelligence techniques. The team members are myself, Dr. Chitra Langamana from University of Waterloo, and work is carried out by Mr. Madhava Herath and Mr. Takshila Tilakanayak. So under this area, we are trying to see how we could apply AI for domestic energy disintegration, and we are looking at how we could disintegrate the household electricity consumption signal into device-wise energy signals. Then how we could develop a real-time data logging device for monitoring household energy consumption, and to collect energy data from domestic households using the device that we develop, and finally to develop a domestic consumer advisory model for energy cost minimization for various households that use a time of day tariff scheme. So here, what is energy disaggregation? So we have the household energy signal. Now, without using individual sensors, we are trying to break this signal into appliance-wise signal. So at any given time, if you apply our algorithm, we will know exactly which device is consuming what amount of energy. So under this main theme, now we have developed a neural network to disaggregate the energy signal into individual device-wise signals. So here we, in one of the studies, we convert 1D data into images, and we use it in the neural network model to obtain results. And this has shown very promising results, and the results were published in ICIIS conference, which was held in University of Peradeniya this year. Then we also considered various parameter tuning options. Here we are considering, we considered different kernel shapes in our disaggregation model, and we have also published a conference paper out of the results, and it was presented in an international conference. Then we have also developed a method for appliance-wise fault detection. So here we try to detect variations in the energy activation signal of various appliances. And we have developed the framework, and we have actually tested it, and the results show that we have an accuracy of more than 94% in the model, and it has also worked very well, and we are planning to publish the results in a conference. So we have developed a data logger for data logging, recording developing a data set for domestic households. So this is the work of the data logger, which is almost complete. So we will use this data logger for collecting domestic energy use data so that we could test whatever we develop with actual models. Then we are also working on developing an online appliance scheduling scheme for domestic households using deep reinforcement learning. Here we are using the reinforcement learning, which is a very novel technique for domestic energy optimization. Here it is based on action and reward, so that it will give a scheme where you could actually, it will give, once we implement the system, once it is developed, it will give the consumer an idea about how he should schedule his appliances to reduce his energy cost. Here you can see if you use the normal method without scheduling, the estimated electricity cost per day will be about 366 rupees. But if you carry out proper scheduling, it could be reduced to 128 rupees in a typical household which has large energy consumption. So during the next year, we have planning to complete several tasks. First, we are trying to develop a system for self-learning, real-time, develop a system for self-learning, real-time energy consumption using neural networks and reinforcement learning. We are also planning to use the device that we used in households to develop a domestic energy consumption dataset. Also, we are planning to train and test the deep reinforcement learning model for carrying out optimization, cost minimization of household energy. Finally, we are looking at, we are planning to take whatever our research findings to the industry. So we are looking for collaborations with CEB and PUCSL so that we could use our knowledge with them. So now we are, last year, I think due to COVID and other reasons, the public, we couldn't do whatever we planned last year, but in the coming year, we hope that it will be a better year for us. And we have planned several journal and conference papers under this project. The next theme is energy, economic and environmental modeling for climate change mitigation. And it is carried out by Ms. Gayashika Fernando, myself, Professor Rahul Atalage, Professor Chandana Pereira, and Professor Shiromi Karunaratna. So here what we do is we have developed a framework to model the energy consumption of Sri Lanka and predict future energy demand. So here from our model, we can predict the energy demand, total primary energy demand for the next till 2050. And with this energy demand, we can also predict carbon dioxide emissions. Then the model, using the model, we could actually develop various climate mitigation scenarios. This year, I think we developed scenarios to attain carbon neutrality in Sri Lanka. So I think that this is a very hot topic which is discussed. People are trying to go for low carbon pathways. So here we considered a base case with different low carbon scenarios. Under this, we considered several low carbon options, such as using high share of renewable energy in power generation, advanced and efficient technologies, consideration of alternative fuels such as biofuels and LNG, nuclear-based power generation, and advanced carbon capture storage in the future. Using these options, we developed 25 different scenarios, and we projected the trajectory of carbon dioxide emissions. So based on these projections, we can select exactly the trajectory that we want to follow for carbon dioxide emissions. And in order to attain that trajectory, this study will give what type of policy options that we need to adapt. So during this year, we plan to complete the development of different emission pathways according to the international IPCC guidelines on shared socioeconomic pathways. Then we are planning to estimate the marginal abatement cost of CO2 reduction when it comes to Sri Lanka. Also, we are planning to promote collaborations with the Sustainable Energy Authority, Climate Change Secretariat, and the CEB. And unlike last year, we couldn't do as much as we expected, but in the coming year, we are working on several high index journal papers and conferences, and we are also looking for several collaborations. Thank you very much, everyone, for listening.